How do you study space dust? There's a bunch of ways that you can do it, and it depends on the spacecraft, where you're going. It depends on how much mass and how much power and how much money you want to put into it. But the main way that you do it is you have a target, and the space dust is fast. It's going like 20 miles in 1 second or 10 miles in 1 second, and it really depends on where you are. It even goes faster than that in some places. It also depends on the size of the particle. But the way you study it is you let it smash into a target so hard that it creates a plasma. And what a plasma is it can be, you can think of it as a piece of, a very, very, very small piece of rock that's just been obliterated. When a star explodes, there's something left behind, and a lot of times that's dust. So that's one of the ways. In fact, nebula, if you look up nebula, that's dust, and that's a lot of times from an exploded star. It can also be from a star that's about to form. So that's one way. There's also another way that there's outside the solar system, outside Pluto's orbit, there's something called the Kuiper Belt, and it's this area of just all these rocks, and they happen to bump into each other, and they happen to collide and graze and touch, and those are going very fast. And so when they do that, you produce dust, and that spirals in toward the sun. So that's another way you can produce dust. It turns out that other things in the solar system are active, like Io, which is a moon of Jupiter, has volcanoes, and you can produce dust that way. So it spews up all this dust, and it goes into the solar system, and it interacts with Jupiter's magnetic field, and actually makes them very, very, very fast, some of these particles. Where's my dust? The question is, does space dust have one of these things? Is it electromagnetic? Or do they gravitationally attract? Well, two things to be gravitationally attractive are, they have to be very, very big. Now, space dust is small, so it doesn't attract itself by gravity. Actually, that's not true. Since there's so much of it, that's how you form planets, is dust will come together and it will combine and form a planet. So it actually does attract gravitationally, but it takes a long time. They're also charged. Some of these particles are charged, and so you have some pluses and some minuses, and then maybe they attract. But the biggest problem is that they're so far apart that it just takes forever for them to be attracted, and they're moving so fast. So If you run by me and you have a magnet stuck in you, and I run by you and I have a magnet stuck on me, it's really hard to attract if we're going 1 mile in a second, right? But if we're going real slow, all of a sudden we can attract together. So in general it doesn't, it can, but in general it doesn't because they're so far apart and they're so small, and the charge on them is so little. You know what? We should really just kind of work together, huh? There's enough dust to go around. There's like tons of this. Falls into the earth every day. Let's work together, huh?